Welcome to Getting Started with Google Shopping APIs. I'm Danny Hermes, a developer programs engineer on the Google Commerce team here at Google. I specialize in the two shopping APIs, the Content API for shopping and the Search API for shopping. Today, we're first going to talk about Google Product Search and how it relates to these APIs. Then, we'll discuss each API at a high level. And finally, we'll review the technical resources available, get our hands dirty, and write some code using client libraries provided for these APIs. Before we can talk about the shopping APIs, we need to talk about Google Product Search. On May 31st, 2012, we announced a change on the Google Commerce blog that will begin to take place this summer. Later this week, on June 27th of 2012, Google Product Search will be renamed to Google Shopping in the US. Throughout this talk, I will still use the term Google Product Search. Here we see google.com/shopping, the Google Product Search landing page. On this page, we try to bring the shopping experience to the web by making it visually pleasing and fun. By typing for a query like remote control car, we see results listing the most relevant RC cars. What's more, we can customize our search based on many other properties directly relevant to remote control cars. For example, we can filter on the type of engine that powers the car, such as gas or electric. We can filter on style of the vehicle, not just RC cars, but also trucks, buggies, and other models. As we scroll down, we also see the drive type of the car, four-wheel or two-wheel, and even the scale to real life. All these features are made possible by collecting as much data as possible from merchants and using it to provide as much useful choices to the end user, the shopper, as possible. In order for an offering to show up in search results, a merchant first must upload the product and all the associated data to the Google Merchant Center. Once this data is uploaded, it can be used to power Google Product Search, to drive traffic through the Google Affiliate Network, or to power a merchant's site through Google Commerce Search. This data can be made available on all Google shopping sites, depending on the preferences of the merchant and the programs they're involved in. So where do the shopping APIs come into play? First, the Search API is just one of the many destinations that product data can end up in. It allows developers to submit search queries programmatically and receive detailed results. Second, the Content API for shopping is one of the primary methods for uploading product data to the Google Merchant Center. Merchants can submit their data in two ways. They can upload via product feeds, which are flat feed files that can be uploaded in many ways, including directly through a web interface, or merchants can upload product data programmatically through the Content API. We won't compare the two methods in depth today, but simply note that each has its own merits, and the Content API will be our focus. As I mentioned before, product data can surface in many different Google properties, and this manifests itself to some degree in the Search API as well. There are three distinct use cases for the Search API for shopping, one of which must be specified with every search query made. The first is the public use case. This most closely mirrors live results on Google.com or Google Product Search. The second is the Google Affiliate Network, or GAN. This allows publishers to partner with developers to bring them qualified traffic. A GAN search query will contain results only from those merchants affiliated with the GAN account making the query. The product links in the search results provide a way to track this qualified traffic, and if a shopper navigates to such links, the affiliate sending the traffic can profit. The third and final use case is Google Commerce Search, or GCS. Google Commerce Search allows merchants to have the power of Google Search directly on their website. By using the Search API, they can send queries from their site to Google, and the most relevant results from their own submitted product data will be returned. Now that we know what the APIs do, let's discuss how they do it. Let's first start with the Content API for shopping. In order to deliver relevant results, we allow merchants to send as much data about each individual product as they can think of. This allows for the enhanced experience we saw, such as allowing relevant and helpful search result filters. As seen here, this data is formatted as XML and has data specific to each attribute of the product. For example, we have a title, a description, a price, and a tax rule, among other things. All of this data and more, if the merchant desires, must be contained in a parent entry element, as we see here. The entry element comes from the Atom XML namespace, as do some other attributes like title, but the majority of the attributes are defined in other namespaces defined as SC and SCP here. As we'll see later, by using a client library, we can worry about the data we send and let the library worry about creating the correct XML representation. Once you've constructed the product entry, you can insert or upload the data by submitting a POST request as seen here. The API allows you to update, delete, and retrieve products as well by submitting put, delete, and get requests, respectively. Each request sent must follow some basic rules. First, each is made to a URI based off the same root and must include the account ID to identify who or what owns the product data being sent. This ID is associated with the Merchant Center account. In addition to a shared root for the URI, each request must be signed with an authorization token. This verifies that the user sending the request truly has access to the Merchant Center account in which they are changing inventory. Finally, the header of the request must identify the type of the data being exchanged. Here, we are sending XML in the body of the request and must identify it as such to Google servers. Upon success, we receive a 201 HTTP status code indicating success. In addition to this, we also see that Google servers identify the response they're returning as XML. As we will see shortly, the response is formatted very similar to the request. Finally, the header location is set to the same URI we made the request to, plus a colon-delimited identifier tacked on at the end. The location is composed of 5 basic parts. The first is the root, content.googleapis.com/v1, and the second is the account ID associated with the data being sent. The next part is the path. When dealing explicitly with product data, the path is items/products. However, the API also allows operations on other data, such as allowing you to programmatically add new users to your Merchant Center account. For this talk, we will simply concentrate on the case where product data is sent. After the path, we have the projection. This is specific to the case where product data is being sent and can be either generic or schema. The value dictates the format of the response returned from Google. The final piece of the URI is the product ID. This is a colon-delimited string composed of the channel where the sale will occur. Here we have online, but local is also allowed, followed by the language of the product and the target country of sale, and finally by the product ID sent in the request. In addition to the headers, such as the successful status code and location, we receive a body in the API response. This is also XML, formatted identically as the request and containing the same information and then some. We can see the same title, description, ID, etc., as well as some new information like when the product entry was published and when it was last edited. Now that we have seen how the Content API works, let's investigate the Search API for shopping. The Search API, intended to be a programmatic relative to Google Product Search, allows submitting queries for shopping data as well as submitting filters on that data. As a result, this API has a smaller set of operations than the Content API for shopping. Since each query is only retrieving data, the only HTTP verb used is a GET request, and the response is returned from the API nearly instantly. Each request sent consists of the exact same root URI, www.googleapis.com/shopping/search/v1/public/products. Rather than specifying an account ID in the URI, an API key is sent with the key parameter. The query, filters, and other settings are sent as URI query parameters as well. Since product data is divided by country, the country URI parameter is required. As I mentioned earlier, there are 3 use cases, one of which is public. The root URI ends with public/products. This indicates that we are making queries against the public source. Google Affiliate Network and Commerce Search queries use a different value in place of public, and this value will depend on the GAN or GCS account ID. Finally, unlike the Content API for shopping, responses can be in either XML format or JSON format. By default, responses are in JSON format, but a specific format can be requested by simply adding the alt query parameter to the request, with a value of Atom for XML and JSON for JSON. When filtering results from a search query, we can use the great deal of data associated with each product. We can define filters by using the brand of the product, the category of the product, for example, shoes, as well as the condition, description, price, and title. We can even query based on the account ID of the merchant selling the product, the global trade ID of the product, or the link to the web page where the product is listed. These attributes can be used in simple filters to specify that the product must have a certain brand or must not be from a certain account ID. These attributes can also be used in more complex filters, as we'll see in the next slide. In addition to using product attributes, by specifying certain URI query parameters, we can define and then refine our query. First is the most basic parameter, Q for query. This allows full text search and follows the same query rules that Google.com search does. Next, the restrict by parameter helps to construct filters that match a certain restriction, such as setting a price between $10 and $20. Using the crowd by parameter, we can create an effect nearly the opposite of restricting. Rather than ensuring all results returned have a specific attribute, we limit the number of results from a given attribute. For example, by crowding by account ID and specifying 3, we ensure that no account will have more than 3 results in our product listings returned from the API. By sending the rank by query parameter, we can rank results according to some preset ranking rules. By specifying rank by equals price :ascending, we can ensure that the first result is the least expensive and prices increase as we go down the list. Unfortunately, there are no relevant ascending or descending ranking rules associated with many of the available attributes, such as title and description, and so they're not supported with rank by. By using facets, you can divide search results into descriptive buckets, creating a histogram based on the restrictions you provide. By specifying facets.enabled equals true, the results returned from the API will be facets rather than individual products. Each facet has a count identifying the total number of products, as well as some other data points identifying the rules which define the bucket. To partition results into 2 buckets, one of products less than $10 and one of products costing $10 or more, we need to specify the facets.include parameter with the value price followed by a colon and a list of price intervals. Here, our list of intervals is the interval from star to 10 and from 10 to star, where star is a wildcard indicating the minimum when used as the left value and maximum when used as the right. As you can see here, the search results we have from the filters we defined in the previous slide are in a dictionary JSON format. The products themselves are in the items key of this dictionary, but before that we also have the total number of items returned, 129, as well as the current item count, 25 returned in this query. The title of the first result, RC Fast Wheels Car, indicates the name of the product, and we see further on that we have the price of $10. Going to the next result, we see a price of $10.07, and even further, $10.99. So, as we requested, the price comes in an ascending order. Now that we have some context and understanding of how the APIs work, let's dig in and check out the client libraries. For the Content API for shopping, we have client library support in 4 programming languages: Java, Python, PHP, and .NET. These libraries are all open source and maintained in large part by Google engineers, but also by other members of the open source community. For each library, we have a comprehensive developer's guide that outlines all the actions you can carry out with the library. Each guide can be found in our documentation at developers.google.com. For example, the Python guide can be found at developers.google.com/shopping-content/developers-guide-python. And the other 3 libraries can be found at similar links simply by replacing the word Python with Java, PHP, or .NET. And that's spelled out DOTNET. For the samples, we're going to be using a dynamic language, Python, to demonstrate use of these libraries in real time. The repository for the Python client library is hosted on Google Code Hosting at code.google.com/p/gdata-python-client. The PyDocs auto-generated documentation can be found at gdata-python-client.googlecode.com/hg/pydocs. Don't worry about writing these links down, they're in the video description. The gdata in gdata-python-client refers to the Google Data Protocol and family of APIs. The Content API for shopping is a member of the gdata API family and so follows the protocol. As we'll see further on, the Search API for shopping is not a member of this set of APIs and so uses a different set of client libraries. The first thing we'll do is install on a Linux system. The project uses Mercurial for version control, so we can use HG, the Mercurial command line tool, to clone the repository. So we're going to run HG clone http://code.google.com/p/gdata-python-client to clone to the local machine in the gdata-python-client directory. After cloning, we're going to enter the directory and we'll install the gdata library by executing sudo python setup.py install. And let me type in my password real quick. You may not need root to install, but it helps to just add sudo to the command just in case. The client library in Python, as well as in the other supported languages, defines a special class that handles all the dirty work of creating requests, obeying the HTTP protocol, and creating well-formed XML. In the Python library, this is called a client, and we need a client before we can do anything else. To instantiate a client, we import the gdata.contentforshopping.client module. This module defines a class custom tailored for the Content API for shopping called Content for Shopping Client. Among other things, this client is used to create the unique URI endpoints to make API requests and to sign requests. When instantiating an instance of the class, we need to pass our account ID in to the constructor. So here we have a client which is going to be equal to gdata.contentforshopping.contentforshopping.client, the name of the class itself, and we're passing in account ID, the keyword, to the constructor with the account ID 8721349. And this is an account ID of my sample account that we're going to be using. In order to authenticate, we will use the OAuth 2 protocol. This protocol has three main parts. First, an application asks a user permission and gets a short-lived code. Second, the application uses that code to exchange for an access token and a long-lived refresh token. And third, when the access token expires, the application uses the refresh token to obtain a new one. In order to carry out this exchange to authenticate with Google, the application will need a client secret and ID. To obtain a token, we need to visit the Google API console as seen here and create a project. So we're just going to click Create Project. So we're in a new API project. After creating the project, we see a list of services we can access. APIs from the gdata family are not on this list, so we need not worry about the Content API for shopping. But we can select the Search API for shopping for our second demo. So let's scroll down and find that. There it is. Search API for shopping. Terms, accept. And now it's been turned on. After selecting a service, we need to click the API Access tab to create our client secret and ID. In our new project, we can click Create an OAuth Client ID to get these values. We enter product name, here shopping-apis-demo, and then proceed to the next step. Here, we specify installed application since we will be running our demo from the interpreter rather than from the web. From there, we can copy and retrieve our client ID and secret. You see here, 723174, etc. is our client ID, and lowercase kg, uppercase k, etc. is the client secret. To use our secret and ID for the OAuth 2 protocol, we import the shopping.gauth module and create a new OAuth2 token providing the ID and secret, the scope of access we're requesting for the user's account, and a user agent which identifies our application. So here, as the client underscore ID keyword, we provide the client ID from the browser. As the client underscore secret keyword, we provide the secret from the browser. And for the scope, we provide googleapis.com/auth/structured content. With this token, we generate an authorization URI by executing authToken.generate authorize URL that we can visit in the browser to begin the authentication process. So here I'll just copy that and go over to my browser. When you or a user visit the authorization URI, they'll be prompted with the name of the application, Shopping API's demo here, and a list of all the access scopes requested. Since we only specified googleapis.com/auth/structured content in our scope, we only see manage your product data in the request. Clicking Allow Access will authorize the application and provide the short-lived code in that first step. We copy this code and we use it to exchange for an access token. Passing the code to the OAuth2 token object, we can complete the exchange by executing authToken.getAccessToken with the string /-4, etc. that we received as the argument. Now we have success. Once we've done this, we must authorize the client with the token so the client can use it to sign requests. So we'll execute authToken.authorize client. And from there, our client is now ready to execute authenticated requests to the Content API for shopping. Recall the basic attributes needed to define a product entry, such as title, description, ID, and price. As I mentioned before, the client library abstracts away all the XML creation and allows you to just concentrate on the product data. The gdata.contentforshopping.data module defines custom data classes which aid the client in the creation of well-formed XML. So if we import gdata.contentforshopping.data, we'll have access to all of those classes. To create a product, we start out with an empty member of the product entry class. Entry equals gdata.contentforshoppingdata.productEntry with no arguments in the constructor. From there, we can set the product ID attribute using a member of the product ID class, which comes from that same module. So entry.product_ID equals gdata.contentforshoppingdata.productID. And we're going to give it the value SKU123 as a string. For simple elements like product ID, passing in the value to the constructor is all that's needed. To set attributes that are shared across all GData APIs, such as title and description, we're going to use the atom.data module, which is also installed with the client library. So we need to import atom.data. And to set the title, we're just going to set entry.title equals atom.data.title Swiss Champ Swiss Army Knife, which is the title of that sample product we saw. So there that is. For properties like price, which also use an XML attribute, we can specify the attribute using a keyword argument. So to set the price, similar to how we did with the product ID, entry.price equals gdata.contentforshopping.data.price, and we give the value $66.95 and use the keyword argument unit to specify US dollars. As you can see here in this merchant account, we have no products at this time. This is the same account that we instantiated the client with, ID 8721349. Once you've set all the product attributes, you can insert by feeding the entry to the insert product method of the shopping client. So here, we're going to get an entry back. Inserted entry equals client.insertProduct, and we're going to pass it entry. The return value, inserted product, will have the same values we sent plus a few more, but it's still a member of the product entry class. As you can see, if we ask for the type of inserted entry, we get gdata.contentforshopping.data.productentry. Now that we've inserted it, we can go back to the Merchant Center account. After executing this request, we can see our product inventory now includes the Swiss Army knife that we inserted. We can use the existing inserted entry object to update the product in our inventory. For example, if we want to change the name, we can set inserted entry.title equals atom.data.title Swiss Chomp awesome Swiss Army knife, rather than just regular Swiss Army knife. And we can update by calling the update product method with the inserted entry as the argument. So we'll get an updated entry, and that'll be equal to client.updateProduct, and we'll pass in the inserted entry. Returning to the Merchant Center, we can see the product name has changed. So we now have Swiss Chomp awesome Swiss Army knife. Finally, to delete this product, we can call the delete product method on the shopping client. So we'll get a response back, delete response equals client.deleteProduct, and we'll pass it updated entry. Unlike inserts and updates, the response is an HTTP response object rather than a product entry. To make sure the delete succeeded, we can check the HTTP status. So we'll first try to see what is in the status, delete response.status, and we got 200, so that means success. And we'll just check the reason as well to see what the reason was, so it's okay. Just as the specification for the content API is bigger, the client library has more material than the client library for the search API. Client library support for the search API for shopping comes in Python, .NET, Java, PHP, Objective-C, Ruby, JavaScript, and more to come. As I mentioned before, the search API for shopping is not a member of Google's GData family of APIs. As a result, it's one of many APIs supported by the Google-API-insert language here-client family of client libraries. These client libraries take advantage of an API feature called a discovery document, which lists all the functionality of the API in a well-defined format. The Content API for shopping does not have a discovery document, but the Search API for shopping does. As you can see here, this document lists the fields that the API supports, describes how authentication works, and even describes the schema for the API. Fields here you see query, for example. Again, we'll start by installing the Python library on a Linux system. This repository has been registered with PyPy, the Python package manager, so we can execute sudo easy install google-api-python-client, just like that. Before we can begin requests, we need to create something similar to the shopping client we saw for the Content API for shopping. So we'll start up the Python terminal. Such an object can be created on the fly from a discovery document. In order to create it, we simply need the name of the API. The search API is named shopping, so we'll set API name equals the string shopping. The content API, on the other hand, is called structured content. And we also need the version of the API. Both shopping APIs here are v1, so we'll set version equal the string v1. In addition, for the search API, we need a developer key, which was created for us the same time our client secret and ID were. Since we specified in that project that we wanted to activate the search API for shopping service, our developer key will be activated and ready to go. If we see here in the API Access tab, we can copy our developer key, capital I, Z, A, S, Y, etc. And we'll paste it into the variable developer key. So developer key, developer underscore key equals the string that we pasted. From the newly installed API client.discovery module, we can use the build function to create our service. So we're gonna, from API client.discovery, import build. And we can execute client equals build. And we're gonna pass in first the API name, which was shopping, as we recall, then the version, and we're gonna use the keyword argument, developer key, and we're gonna pass in the developer key that we got from the API console. Now you'll notice developer key, the variable name of the argument is in camel case, but usually in Python we don't do this. Well, the reason for that is because in the discovery doc it's defined that way. So after creating this client, we call the products method to get a resource that allows us to make API calls. So we'll say resource equals client.products, and we'll call that method with no arguments. To motivate why we're doing this, notice that in the specification in the discovery doc, the API actions are listed in the products key. So we're actually accessing the actions available in a corresponding fashion. To make queries, we use the list method on this resource and pass in our URI query parameters as keyword arguments. To search the public source in the United States for a remote control car, we call response equals resource.list, and we're going to pass in country equals US, source equals public, and then Q for our query equals remote control car. And we're going to execute that request. For your viewing pleasure, we'll pretty print this dictionary to examine its content. So I'm going to import pprint for pretty print, and then I'm going to pprint.pprint the response that we received from the API. And as you can see, it's much larger than this screen, but it's very similar to what we saw when we made the request through the browser. To restrict this query to cars between $10 and $20, we can just add another keyword. So we have the same command from before, response equals resource.list, and pass in the argument country equals US, source equals public, Q equals remote control car, and we add another argument, restrict by equals the string price equals the open square paren 10 and then 20, and we close the string, and then we execute that same request. And what we see, if we pretty print that, results very similar to what we had before, except now our prices are going to be between $10 and $20. So you see here, we have a price of $19.19. Going up to the next one, we see a price of $17.99. So you see the prices are within that range that we've defined. Finally, to rank these by price from lowest to highest, we submit the same request, resource.list equals country, etc., and we add the rank by parameter with the value price colon ascending. This is the same request that we submitted in the browser. If we pretty print this, we see now starting from the bottom, we'll get the item with the highest price in the list. So we see $12.99, then the next one up has a price of $12.99, same value, but not bigger. Then we have $12.95, and we go up one higher, another $12.95, and one high. Okay, so as you can see, it's ascending. And there's an exact correspondence with the keyword parameters that we're using here and the query parameters that get tacked on to the URI in the API request. So using the client library amounts to understanding the filter parameters. Thank you for watching this video. I enjoyed introducing you to these APIs, and I hope you enjoyed it too. For more on these APIs, check out our developer documentation at developers.google.com/shopping-content and developers.google.com/shopping-search. For questions, we're always at the ready on the forums at groups.google.com/group/content-API-4-shopping and groups.google.com/group/search-API-4-shopping. And of course, no need to memorize these. They are in the video description. Thanks and have a nice day.